The Northrop B-2 Spirit, also known as the stealth bomber, is an American strategic bomber, featuring low observable stealth technology designed for penetrating dense anti-aircraft defenses. It is able to deploy both conventional and nuclear weapons. The bomber has a crew of 2 and can drop up to 8,500 lb-class JDAM GPS-guided bombs, or 16 2,400 lb B-83 nuclear bombs. The B-2 is the only aircraft that can carry large air-to-surface standoff weapons in a stealth configuration. Development originally started under the Advanced Technology Bomber project during the Carter administration, and its performance was one of his reasons for the cancellation of the supersonic Rockwell B-1 Lancer. ATB continued during the Reagan administration, but worries about delays in its introduction led to the reinstatement of the B-1 program as well. Program costs rose throughout development. Designed and manufactured by Northrop Grumman with assistance from Boeing, the cost of each aircraft averaged $737 a million. Total procurement costs averaged $929 a million per aircraft, which includes spare parts, equipment, retrofitting, and software support. The total program cost including development, engineering and testing, averaged $2.1 billion per aircraft in 1997. Because of its considerable capital and operating costs, the project was controversial in the U.S. Congress and among the Joint Chiefs of Staff. The winding down of the Cold War in the latter portion of the 1980s dramatically reduced the need for the aircraft, which was designed with the intention of penetrating Soviet airspace and attacking high-value targets. During the late 1980s and 1990s, Congress slashed plans to purchase 132 bombers to 21. In 2008, a B-2 was destroyed in a crash shortly after takeoff, and the crew ejected safely. A total of 20 B-2s remain in service with the United States Air Force, who plan to operate the B-2 until 2058. The B-2 is capable of all-altitude attack missions up to 50,000 feet, with a range of more than 6,000 nautical miles unrefueled and over 10,000 nautical miles with one refueling. Though originally designed primarily as a nuclear bomber, it was first used in combat to drop conventional bombs on Serbia during the Kosovo War in 1999, and saw continued use during the war in Iraq and in Afghanistan. Development, origins: in the mid-1970s, the search for a new U.S. strategic bomber to replace the Boeing B-52 Stratofortress was underway, to no avail. First the B-70 and then the B-1A were cancelled after only prototypes of each aircraft were built. The B-70 was intended to fly above and beyond defensive interceptor aircraft, only to find these same attributes made it especially vulnerable to surface-to-air missiles. The B-1 attempted to avoid SAMs by flying close to the ground to use terrain to mask its radar signature, only to face a new generation of interceptors with look-down shoot-down capabilities that could attack them from above. By the mid-1970s, it was becoming clear that there was a different way to avoid missiles and intercepts. Known today as stealth. The concept was to build an aircraft with an airframe that deflected or absorbed radar signals so that little was reflected back to the radar unit. An aircraft having stealth characteristics would be able to fly nearly undetected and could be attacked only by weapons and systems not relying on radar. Although such possibilities existed, such as human observation, their relatively short detection range allowed most aircraft to fly undetected by defenses, especially at night. In 1974, DARPA requested information from U.S. aviation firms about the largest radar cross-section of an aircraft that would remain effectively invisible to radars. Initially, Northrop and McDonnell Douglas were selected for further development. Lockheed had experience in this field due to developing the Lockheed A-12 and SA-71, which included a number of stealthy features, notably its canted vertical stabilizers, the use of composite materials in key locations, and the overall surface finish in radar-absorbing paint. A key improvement was the introduction of computer models used to predict the radar reflections from flat surfaces where collected data drove the design of a faceted aircraft. Development of the first such design started in 1975 with the Hopeless Diamond, a model Lockheed built to test the concept. Plans were well advanced by the summer of 1975, when DARPA started the Experimental Survivability Testbed project. Northrop and Lockheed were awarded contracts in the first round of testing. Lockheed received the sole award for the second test round in April 1976, leading to the Have Blue program. ATB program. By 1976, these programs progressed to where a long-range strategic stealth bomber appeared viable. President Carter was aware of these developments during 1977, and it appears to have been one of the major reasons the B-1 was cancelled. Further studies were ordered in early 1978, by which point the Have Blue platform had flown and proven the concepts. During the 1980 presidential election in 1979, Ronald Reagan repeatedly stated that Carter was weak on defense, and used the B-1 as a prime example. In return, on August 22, 1980, the Carter administration publicly disclosed that the United States Department of Defense was working to develop stealth aircraft, including a bomber. The Advanced Technology Bomber began in 1979. Full development of the Black Project followed, and was funded under the codename Aurora. After the evaluations of the company's proposals, the ATB competition was narrowed to the Northrop Boeing and Lockheed Rockwell teams, with each receiving a study contract for further work. Both teams used flying wing designs. Northrop had prior experience developing the YB-35 and YB-49 flying wing aircraft. The Northrop design was larger while the Lockheed design included a small tail. In 1979, designer Hal Markarian produced a sketch of the aircraft that bore considerable similarities to the final design. The Air Force originally planned to procure 165 of the ATB bomber. The Northrop Boeing team's ATB design was selected over the Lockheed Rockwell design on October 20, 1981. The Northrop design received the designation B-2 and the name Spirit. The bomber's design was changed in the mid-1980s when the mission profile was changed from high altitude to low altitude, terrain following. The redesign delayed the B-2's first flight by 2 years and added about $1 billion to the program's cost. An estimated $23 billion was secretly spent for research and development on the B-2 by 1989. MIT engineers and scientists helped assess the mission effectiveness of the aircraft under a 5-year classified contract during the 1980s. Secrecy and espionage. Both during development and in service, there has been considerable importance placed to the security of the B-2 and its technologies. Staff working on the B-2 in most, if not all, capacities have to achieve a level of special access clearance, and undergo extensive background checks carried out by a special branch of the Air Force. For the manufacturing, a former Ford automobile assembly plant in Pico Rivera, California, was acquired and heavily rebuilt. The plant's employees were sworn to complete secrecy regarding their work. To avoid the possibility of suspicion, components were typically purchased through foreign companies, military officials would visit out of uniform, and staff members were routinely subjected to polygraph examinations. The secrecy extended so far that access to nearly all information on the program by both Government Accountability Office and virtually all members of Congress itself was severely limited until mid-1980s. In 1984, a Northrop employee, Thomas Cavanaugh, was arrested for attempting to sell classified information to the Soviet Union. The information was taken from Northrop's Pico Rivera, California factory. Cavanaugh was eventually sentenced to life in prison and released on parole in 2001. The B-2 was first publicly displayed on November 22, 1988 at Air Force Plant 42, Palmdale, California, where it was assembled. This viewing was heavily restricted, and guests were not allowed to see the rear of the B-2. However, Aviation Week editors found that there were no airspace restrictions above the presentation area and took photographs of the aircraft's then-secret planform and suppressed engine exhausts from the air, to the USAF's disappointment. The B-2's first public flight was on July 17, 1989 from Palmdale to Edwards AFB. In October 2005, Nashir Gawadia, a design engineer who worked on the B-2's propulsion system, was arrested for selling B-2-related classified information to foreign countries. On August 9, 2010, Gowadia was convicted in the United States District Court for the District of Hawaii on 14 of 17 charges against him. On January 24, 2011, Gowadia was sentenced to 32 years in prison. Program costs and procurement. A procurement of 132 aircraft was planned in the mid-1980s, but was later reduced to 75. By the early 1990s, the Soviet Union dissolved, effectively eliminating the Spirit's primary Cold War mission. Under budgetary pressures and congressional opposition, in his 1992 State of the Union address, President George H.W. Bush announced B-2 production would be limited to 20 aircraft. In 1996, however, the Clinton administration, though originally committed to ending production of the bombers at 20 aircraft, authorized the conversion of a 21st bomber, a prototype test model, to Block 30 fully operational status at a cost of nearly $500 a million. In 1995, Northrop made a proposal to the USAF to build 20 additional aircraft with a flyaway cost of $566 a million each. The program was the subject of public controversy for its cost to American taxpayers. In 1996, the General Accounting Office disclosed that the USAF's B-2 bombers will be, by far, the most costly bombers to operate on a per-aircraft basis, costing over 3 times as much as the B-1B and over 4 times as much as the B-52H. In September 1997, each hour of B-2 flight necessitated 119 hours of maintenance in turn. Comparable maintenance needs for the B-52 and the B-1B are 53 and 60 hours respectively for each hour of flight. A key reason for this cost is the provision of air-conditioned hangars large enough for the bomber's 172 ft wingspan, which are needed to maintain the aircraft's stealthy properties, particularly its low observable stealthy skins. Maintenance costs are about $3.4 a million a month for each aircraft. The total military construction cost related to the program was projected to be $553.6 a million in 1997 dollars. The cost to procure each B-2 was $737 a million in 1997 dollars, based only on a fleet cost of $15 and 48 cents a billion. The procurement cost per aircraft as detailed in GAO reports, which includes spare parts and software support, was $929 a million per aircraft in 1997 dollars. The total program cost projected through 2004 was $44 and 75 cents a billion in 1997 dollars. This includes development, procurement, facilities, construction, and spare parts. The total program cost averaged $2 and 13 cents a billion per aircraft. The B-2 may cost up to $135,000 per flight hour to operate in 2010, which is about twice that of the B-52 and B-1. Opposition. In its consideration of the fiscal year 1990 defense budget, the House Armed Services Committee trimmed $800 a million from the B-2 research and development budget, while at the same time staving off a motion to end the project. Opposition in committee and in Congress was mostly broad and bipartisan, with Congressmen Ron Dellums, John Kasich, and John G. Rowland authorizing the motion to end the project, others in the Senate, such as Jim Exon and John McCain, also opposing the project. The escalating cost of the B-2 program and evidence of flaws in the aircraft's ability to elude detection by radar, were among factors that drove opposition to continue the program. At the peak production period specified in 1989, the schedule called for spending $7 a billion to $8 a billion per year in 1989 dollars, something Committee Chair Leigh Aspen said won't fly financially. In 1990, the Department of Defense accused Northrop of using faulty components in the flight control system. The threat posed by bird ingestion potentially damaging engine fan blades also required redesigning. In time, a number of prominent members of Congress began to oppose the program's expansion, including former Democratic presidential nominee John Kerry, who cast votes against the B-2 in 1989, 1991 and 1992 while a U.S. Senator, representing Massachusetts. By 1992, Republican President George H.W. Bush called for the cancellation of the B-2 and promised to cut military spending by 30% in the wake of the collapse of the Soviet Union. In October 1995, former Chief of Staff of the United States Air Force, General Mike Ryan, and former Chairman of the Joint Chiefs of Staff, General John Shalikashvili, strongly recommended against congressional action to fund the purchase of any additional B-2s, arguing that to do so would require unacceptable cuts in existing conventional and nuclear-capable aircraft, and that the military had greater priorities in spending a limited budget. Some B-2 advocates argued that procuring 20 additional aircraft would save money because B-2s would be able to deeply penetrate anti-aircraft defenses and use low-cost, short-range attack weapons rather than expensive standoff weapons. However, in 1995, the Congressional Budget Office, and its Director of National Security Analysis, found that additional B-2s would reduce the cost of expended munitions by less than $2 billion in 1995 during the first 2 weeks of the conflict, in which the Air Force predicted bombers would make their greatest contribution. A small fraction of the $26.8 billion life cycle cost that the CBO projected an additional 20 B-2s would cost. In 1997, as ranking member of the House Armed Services Committee and National Security Committee, Congressman Ron Dellums, a longtime opponent of the bomber, cited 5 independent studies and offered an amendment to that year's Defense Authorization Bill to cap production of the bombers to the existing 21 aircraft. The amendment was narrowly defeated. Nonetheless, Congress did not approve funding for the purchase of any additional B-2 bombers. Further developments: a number of upgrade packages have been applied to the B-2. In July 2008, the B-2's onboard computing architecture was extensively redesigned. It now incorporates a new integrated processing unit that communicates with systems throughout the aircraft via a newly installed fiber optic network. A new version of the operational flight program software was also developed, with legacy code converted from the Jovial programming language used beforehand to standard C. Updates were also made to the weapon control systems to enable strikes upon non-static targets, such as moving ground vehicles. On December 29, 2008, Air Force officials awarded a $468 million contract to Northrop Grumman to modernize the B-2 fleet's radars. Changing the radar's frequency was required as the U.S. Department of Commerce has sold that radio spectrum to another operator. In July 2009, it was reported that the B-2 had successfully passed a major USAF audit. In 2010, it was made public that the Air Force Research Laboratory had developed a new material to be used on the part of the wing trailing edge subject to engine exhaust, replacing existing material that quickly degraded. In 2013, the USAF contracted for the Defensive Management System Modernization Program to replace the antenna system and other electronics to increase the B-2's frequency awareness. In July 2010, political analyst Rebecca Grant speculated that when the B-2 becomes unable to reliably penetrate enemy defenses, the Lockheed Martin F-35 Lightning II may take on its strike interdiction mission, carrying B-61 nuclear bombs as a tactical bomber. However, in March 2012, the Pentagon announced that a $2 billion, 10-year-long modernization of the B-2 fleet was to begin. The main area of improvement would be replacement of outdated avionics and equipment. It was reported in 2011 that the Pentagon was evaluating an unmanned stealth bomber, characterized as a mini B-2, as a potential replacement in the near future. In 2012, Air Force Chief of Staff General Norton Schwartz stated the B-2's 1980s-era stealth would make it less survivable in future contested airspaces, so the USAF is to proceed with the next-generation bomber despite overall budget cuts. The next-generation bomber was estimated, in 2012, to have a projected overall cost of $55 billion. The Common Very Low Frequency Receiver upgrade will allow the B-2s to use the same very low-frequency transmissions as the SSBN so as to continue in the nuclear mission until the Mobile User Objectives System is fielded. In 2014, the USAF outlined a series of upgrades including nuclear warfighting, a new integrated processing unit, the ability to carry cruise missiles, and threat warning improvements. Design overview. The B-2 Spirit was developed to take over the USAF's vital penetration missions, able to travel deep into enemy territory to deploy their ordnance, which could include nuclear weapons. The B-2 is a flying-wing aircraft, meaning it has no fuselage or tail. The blending of low observable technologies with high aerodynamic efficiency and large payload gives the B-2 significant advantages over previous bombers. Low observability provides a greater freedom of action at high altitudes, thus increasing both range and field of view from board sensors. The U.S. Air Force reports its range is approximately 6,000 nautical miles. At cruising altitude, the B-2 refuels every 6 hours, taking on up to 50 short tons of fuel at a time. Due to the aircraft's complex flight characteristics and design requirements to maintain very low visibility to multiple means of detection, both the development and construction of the B-2 required pioneering use of computer-aided design and manufacturing technologies. Northrop Grumman is the B-2's prime contractor. Other contributing subcontractors include Boeing, Raytheon, GE and Vought Aircraft. The B-2 bears a resemblance to earlier Northrop aircraft. The YB-35 and YB-49 were both flying-wing bombers that had been cancelled in development in the early 1950s, allegedly for political reasons. The resemblance goes as far as B-2 and YB-49 having the same wingspan. As of September 2013, about 80 pilots fly the B-2. Each aircraft has a crew of 2, a pilot in the left seat and mission commander in the right, and has provisions for a third crew member if needed. For comparison, the B-1B has a crew of 4 and the B-52 has a crew of 5. The B-2 is highly automated and, unlike most two-seat aircraft, one crew member can sleep in a camp bed, use a toilet, or prepare a hot meal while the other monitors the aircraft. Extensive sleep cycle and fatigue research was conducted to improve crew performance on long sorties. Armaments and equipment. The B-2, in the envisaged Cold War scenario, was to perform deep penetrating nuclear strike missions, making use of his stealthy capabilities to avoid detection and interception throughout missions. There are 2 internal bomb bays in which munitions are stored either on a rotary launcher or 2 bomb racks. The carriage of the weapons loadouts internally results in less radar visibility than external mounting of munitions. Nuclear ordnance includes the B-61 and B-83 nuclear bombs. The AGM-129 ACM cruise missile was also intended for use on the B-2 platform. It was decided, in light of the dissolution of the Soviet Union, to equip the B-2 for conventional precision attacks as well as for the strategic role of nuclear strike. The B-2 features a sophisticated GPS-aided targeting system that uses the aircraft's APQ-181 synthetic aperture radar to map out targets prior to deployment of GPS-aided bombs, later superseded by the Joint Direct Attack munition. In the B-2's original configuration, up to 16 JDAMs or JDAMs could be deployed. An upgrade program in 2004 raised the maximum carryable capacity to 80 JDAMs. The B-2 has various conventional weapons in its arsenal, able to equip Mark 82 and Mark 84 bombs, CBU-87 combined effects munitions, Gator mines, and the CBU-97 sensor-fused weapon. In July 2009, Northrop Grumman reported the B-2 was compatible with the equipment necessary to deploy the 30,000 lb massive ordnance penetrator, which is intended to attack reinforced bunkers. Up to 2 MOPs could be equipped in the B-2's bomb bays. The B-2 is the only platform compatible with the MOP as of 2012. As of 2011, the AGM-158 JASSM cruise missile is an upcoming standoff munition to be deployed on the B-2 and other platforms. This is to be followed by the long-range standoff weapon which may give the B-2 a standoff nuclear capability for the first time. Avionics and Systems. In order to make the B-2 more effective than any previous bomber, it has integrated many advanced and modern avionics systems into its design. These have been modified and improved in light of the switch to conventional warfare missions. The B-2 features the low probability of intercept AN/APQ-181 multi-mode radar, a fully digital navigation system that is integrated with terrain-following radar and global positioning system guidance, and a defensive management system to inform the flight crew against possible threats. The onboard DMS is capable of automatically assessing the detection capabilities of identified threats and indicated targets. For safety and fault detection purposes, an onboard test system is interlinked with the majority of avionics on the B-2 to continuously monitor the performance and status of thousands of components and consumables. It also provides post-mission servicing instructions for ground crews. In 2008, many of the standalone distributed computers on board the B-2, including the primary flight management computer, were being replaced by a single integrated system. In addition to periodic software upgrades and the introduction of new radar-absorbent materials across the fleet, the B-2 has had several major upgrades to its avionics and combat systems. For battlefield communications, both Link-16 and a high-frequency satellite link have been installed, compatibility with various new munitions has been undertaken, and the AN/APQ-181 radar's operational frequency was shifted in order to avoid interference with other operators' equipment. The upgraded radar features entirely replaced arrays by those of a newer design. The AN/APQ-181 is now an active electronically scan array radar. Flight controls. In order to address the inherent flight instability of a flying wing aircraft, the B-2 uses a complex quadruplex computer-controlled fly-by-wire flight control system that can automatically manipulate flight surfaces and settings without direct pilot inputs in order to maintain aircraft stability. The flight computer receives information on external conditions such as the aircraft's current airspeed and angle of attack via pitot static sensing plates, as opposed to traditional pitot tubes which would negatively affect the aircraft's stealth capabilities. The flight actuation system incorporates both hydraulic and electrical servo-actuated components, and it was designed with a high level of redundancy and fault diagnostic capabilities. Northrop had investigated several means of applying directional control that would least infringe on the aircraft's radar profile, eventually settling on a combination of split-brake rudders and differential thrust. Engine thrust became a key element of the B-2's aerodynamic design process early on. Thrust not only affects drag and lift but pitching and rolling motions as well. 4 pairs of control surfaces are located along the wing's trailing edge. While most surfaces are used throughout the aircraft's flight envelope, the inner elevons are normally only in use at slow speeds, such as landing. To avoid potential contact damage during takeoff and to provide a nose-down pitching attitude, all of the elevons remain drooped during takeoff until a high enough airspeed has been attained. Stealth, its low observable, or stealth, characteristics enable the undetected penetration of sophisticated anti-aircraft defenses and to attack even heavily defended targets. This stealth comes from a combination of reduced acoustic, infrared, visual and radar signatures to evade the various detection systems that could be used to detect and be used to direct attacks against an aircraft. The majority of the B-2 is made out of a carbon graphite composite material that is stronger than steel and lighter than aluminum. Perhaps most crucially, it also absorbs a significant amount of radar energy. Reportedly, the B-2 has a radar signature of about 0.1 AM2. The bomber does not always fly stealthily. When nearing air defenses, pilots stealth up the B-2, the details of which are secret. The aircraft disappears from radar, except briefly when the bomb bay opens. The bomber remains vulnerable, however, to visual interception by fighters. No missile has ever been fired at a B-2 as of September 2013. In contrast to the flat surfaces of the earlier F-117 Nighthawk, the B-2 is composed of many curved and rounded surfaces across its exposed airframe to deflect radar beams. Additional reduction in its radar signature was achieved by the use of various radar-absorbent materials to absorb and neutralize radar beams. The B-2's clean, low-drag flying wing configuration not only gives it exceptional range but is also beneficial to reducing its radar profile. The B-2 is assembled with unusually tight tolerances to avoid leaks as they could increase its radar signature. Another design feature is the placement of the engines, which are buried within the B-2's wing to conceal the engine's fans and minimize thermal visibility of the exhaust. The original design had tanks for a control-inhibiting chemical, but this was replaced in production aircraft by a contrail sensor that alerts the crew when they should change altitude. To reduce optical visibility during daylight operations, the B-2 was painted in an anti-reflective paint. Innovations such as alternate high-frequency material and automated material application methods were also incorporated into the aircraft to enhance its radar-absorbent properties and lower maintenance requirements. In early 2004, Northrop Grumman began applying a newly developed AHFM to operational B-2s. In order to protect the operational integrity of its sophisticated radar-absorbent material and coatings, each B-2 is kept inside a climate-controlled hangar large enough to accommodate its 172-foot wingspan. Operational history. The first operational aircraft, christened Spirit of Missouri, was delivered to Whiteman Air Force Base, Missouri, where the fleet is based, on December 17, 1993. The B-2 reached initial operational capability on January 1, 1997. Depot maintenance for the B-2 is accomplished by U.S. Air Force contractor support and managed at Oklahoma City Air Logistics Center at Tinker Air Force Base. Originally designed to deliver nuclear weapons, modern usage has shifted towards a flexible role with conventional and nuclear capability. The B-2's combat debut was in 1999, during the Kosovo War. It was responsible for destroying 33% of selected Serbian bombing targets in the first 8 weeks of U.S. involvement in the war. During this war, B-2s flew non-stop to Kosovo from their home base in Missouri and back. The B-2 was the first aircraft to deploy GPS satellite-guided JDAM smart bombs in combat use in Kosovo. The use of JDAMs and precision-guided munitions effectively replaced the controversial tactic of carpet bombing, which had been harshly criticized due to it causing indiscriminate civilian casualties in prior conflicts, such as the 1991 Gulf War. On May 7, 1999, a B-2 dropped 5 JDAMs on a target building that was actually the Chinese embassy, killing several staff. The B-2 saw service in Afghanistan, striking ground targets in support of Operation Enduring Freedom. With aerial refueling support, the B-2 flew one of its longest missions to date from Whiteman Air Force Base, Missouri to Afghanistan and back. B-2s would be stationed in the Middle East as a part of a U.S. military buildup in the region from 2003. The B-2's combat use preceded a U.S. Air Force declaration of full operational capability in December 2003. The Pentagon's Operational Test and Evaluation 2003 annual report noted that the B-2's serviceability for fiscal year 2003 was still inadequate, mainly due to the maintainability of the B-2's low observable coatings. The evaluation also noted that the defensive avionics suite also had shortcomings with pop-up threats. During the Iraq War, B-2s operated from Diego Garcia and an undisclosed forward operating location. Other sorties in Iraq have launched from Whiteman AFB. As of September 2013, the longest combat mission has been 44.3 hours. Forward operating locations have been previously designated as Anderson Air Force Base in Guam and RAF Fairford in the United Kingdom, where new climate-controlled hangars have been constructed. B-2s have conducted 27 sorties from Whiteman AFB and 22 sorties from a forward operating location, releasing more than 1,500,000 pounds of munitions, including 583 JDAM smart bombs in 2003. In response to organizational issues and high-profile mistakes made within the Air Force, all of the B-2s, along with the nuclear-capable B-52s and the Air Force's intercontinental ballistic missiles, were transferred to the newly formed Air Force Global Strike Command on February 1, 2010. In March 2011, B-2s were the first U.S. aircraft into action in Operation Odyssey Dawn, the UN-mandated enforcement of the Libyan no-fly zone. 3 B-2s dropped 40 bombs on a Libyan airfield in support of the UN no-fly zone. The B-2s flew directly from the U.S. mainland across the Atlantic Ocean to Libya. A B-2 was refueled by Allied tanker aircraft 4 times during each round-trip mission. In August 2011, The New Yorker reported that prior to the May 2011 U.S. Special Forces raid into Abbottabad, Pakistan that resulted in the death of Osama bin Laden, U.S. officials had considered an airstrike by one or more B-2s as an alternative. An airstrike was rejected because of damage to civilian buildings in the area from using a bunker-busting bomb. There were also concerns an airstrike would make it difficult to positively identify bin Laden's remains, and so concluding he was in fact dead would be difficult. On March 28, 2013, two B-2s flew a round trip of 13,000 miles from Whiteman Air Force Base in Missouri to South Korea, dropping dummy ordnance on the JDAM target range. The mission, part of the annual South Korean-United States military exercises, was the first time that B-2 seconds overflew the Korean peninsula. Tensions between North and South Korea were high during and after the exercise. North Korea protested against the participation of the B-2s and made threats of retaliatory nuclear strikes against South Korea and the United States. Operators: United States Air Force, Global Strike Command, 509th Bomb Wing, Whiteman Air Force Base, Missouri. 13th Bomb Squadron 2005-325th Bomb Squadron 1998-2005, 393d Bomb Squadron 1993-394th Combat Training Squadron 1996. Air Combat Command, 53d Wing, Eglin Air Force Base, Florida. 72d Test and Evaluation Squadron 1998. 57th Wing, Nellis AFB, Nevada. 325th Weapons Squadron 2005-715th Weapons Squadron 2003-05. Air National Guard, 131st Bomb Wing, Whiteman Air Force Base 2009. 110th Bomb Squadron. Air Force Materiel Command, 412th Test Wing, Edwards Air Force Base, California. 419th Flight Test Squadron 1997-420th Flight Test Squadron 1992-97. Air Force Systems Command, 6510th Test Wing, Edwards AFB 1989-92. 6520th Flight Test Squadron. Accidents. On February 23, 2008, B-2 Spirit of Kansas, 89-0127 crashed on the runway shortly after takeoff from Anderson Air Force Base in Guam. Spirit of Kansas had been operated by the 393rd Bomb Squadron, 509th Bomb Wing, Whiteman Air Force Base, Missouri, and had logged 5,176 flight hours. It was the first crash of a B-2. The two-person crew ejected safely from the aircraft and survived the crash. The aircraft was completely destroyed, a hull loss valued at $1.4 billion. After the accident, the Air Force took the B-2 fleet off operational status until clearing the fleet for flight status 53 days later on April 15, 2008. The cause of the crash was later determined to be moisture in the aircraft's port transducer units during air data calibration, which distorted the information being sent to the bomber's air data system. As a result, the flight control computers calculated an inaccurate airspeed, and a negative angle of attack, causing the aircraft to pitch upward 30 degrees during takeoff. In February 2010, another serious incident involving a B-2 occurred at Anderson AFB. The aircraft involved was AV-11 Spirit of Washington. The aircraft was severely damaged by fire while on the ground and underwent 18 months of temporary repairs in order to enable it to fly back to the mainland for more comprehensive repairs. Spirit of Washington was repaired and returned to service in December 2013. At the time of the accident, the USAF had no training to deal with tailpipe fires on the B-2s. Aircraft on display. No operational B-2s have been retired by the Air Force to be put on display. B-2s have made periodic appearances on ground display at various air shows. B-2 Test Article, the second of two built without engines or instruments for static testing, was placed on display in 2004 at the National Museum of the United States Air Force near Dayton, Ohio. The test article passed all structural testing requirements before the airframe failed. The museum's restoration team spent over a year reassembling the fractured airframe. The display airframe is marked to resemble the Spirit of Ohio, the B-2 used to test the design's ability to withstand extreme heat and cold. The exhibit features Spirit of Ohio's nose wheel door, with its fire and ice artwork, which was painted and signed by the technicians who performed the temperature testing. The restored test aircraft is on display in the museum's Cold War Gallery. From 1989 to 2004, the South Dakota Air and Space Museum located on the grounds of Ellsworth Air Force Base displayed the 10 short-ton Honda Stealth, a 60% scale mock-up of a stealthy bomber which had been built by North American Honda in 1988 for an advertising campaign. Honda donated the model to the museum in 1989, on condition that the model be destroyed if it was ever replaced with a different example. The museum received a B-1 Lancer for display in 2005 and destroyed the mock-up. Specifications. Data from USAF Fact Sheet, Pace, SPIC, General Characteristics, Crew, 2 Pilot and Commander, Length, 69 feet, Wingspan, 172 feet, Height, 17 feet, Wing Area, 5,140 FTA², Empty weight, 158,000 pounds, Loaded weight, 336,500 pounds, Max takeoff weight, 376,000 pounds, Power plant, Fora, General Electric F-118 GE100 non-afterburning turbofans, 17,300 pound forces each, fuel capacity, 167,000 pounds, performance, maximum speed, Mach 0.95 at 40,000 feet altitude / Mach 0.95 at sea level, cruise speed, Mach 0.85 at 40,000 feet altitude, range, 6,000 mi, service ceiling, 50,000 feet, wing loading, 67.3 pounds FTA², thrust weight, 0.205, armament, 2 internal bays for 50,000 lb of ordnance and payload, 80 500 pounds class bombs mounted on bomb rack assembly, 36 750 pounds CBU class bombs on BRA, 16 2,000 pounds class bombs mounted on rotary launcher assembly, 16 B-61 or B-83 nuclear bombs on RLA, individual aircraft. Sources, B2spiritfaz.org, see also. Related lists, List of active United States military aircraft, List of bomber aircraft, List of flying wing aircraft, List of aerospace megaprojects, references, notes. Bibliography. Further reading, Richardson, Doug. Northrop B-2 Spirit. New York, Smithmark Publishers Incorporated, 1991. ISBN 0-8317-1404-2. Sweetman, Bill. Inside the Stealth Bomber. St. Paul, Minnesota, MBI Publishing, 1999. ISBN 0-7603-0627-3. Winchester, Jim, ed. Northrop B-2 Spirit. Modern Military Aircraft. Rochester, Kent, UK, Grange Books plc, 2004. ISBN 1-84013-640-5. The World's Great Stealth and Reconnaissance Aircraft. New York, Smithmark, 1991. ISBN 0-8317-9558-1. External links, B-2 Spirit Fact Sheet and Gallery on U.S. Air Force site, B-2 Spirit page on Northrop Grumman site, B-2 Spirit Stealth Bomber on airforce-technology.com, B-2 Stealth Bomber article on how it works daily, B-2 Spirit page at globalsecurity.org.